Alright, starting off our third section, we're going to talk a little bit about polynomials. As far as what a polynomial in X is, we're going to go ahead and let A0, A1, A2, up through AN, all of those are subscripted, be just some random real numbers that we have, okay? But they are constants. And here in the thing that we're subscripting them by is some non-negative integer. Now, a polynomial in X is an expression of the following form. A n x to the n, and then we're going to keep dropping down powers. Until we count down to all the way down to a 0th power, okay? And here we need an, this constant, to not be 0. Any of the others could be though, okay? So these could all be 0 for all we know, okay? Or any one of them could be. Here the basic form is that all of these that's an an minus 1 there. But, so any one of these could be 0, except for this one. But throughout this, the basic form of a polynomial is you have a variable to a power with some leading constant on it. And then you add all of them up together, okay? There's some important terminology for this. So again, consider that polynomial. Here, the A0, the A1x, the A2x squared, and all of these different pieces that are added together, they're each called terms of the polynomial. We also call all of the constants on the front, those are called coefficients. As such, A0 is the constant term. It is also the constant coefficient, while an is the leading coefficient, because written in standard form, the polynomial always has that as part of the leading term. The highest power n is called the degree of the polynomial. A bit more terminology, we have some special polynomials based on the number of terms. If we have a monomial, if you think mono, then it means that it has one term. A binomial, similarly, has two terms. And then finally, a trinomial has three terms. Of course, if you remember, poly means many, then the way to understand this is that a polynomial has many terms in general. So let's do some examples. Let's go ahead and write the following polynomials in standard form. Then we're going to identify the degree and the leading coefficient of the polynomial. Standard form is helpful for doing this. So standard form has you write each of the terms in descending with descending powers. So the highest power in all of these is the 7th power. So negative 5x to the 7th. For the next highest power is squared. Then we have 3x. So that's the first power. And then we have technically the 0th power. Anything to the 0 is 1, so we just don't even write it there. So it's negative 2. So the leading coefficient is negative 5. And the degree would be 7. Similarly, this has the highest power, negative 9x squared. X squared is 2 is the highest power, plus 4. So this would be our leading coefficient. And our degree would be 2. Finally, here, it's already in standard form, And what is the degree? Well, you'll notice that 8 doesn't have any x's, but it does. It has an x to the 0 power. And since it has x to the 0 power, its degree is 0. Now it is time for you to try an example. So go ahead and write the polynomial 6 minus 7x cubed plus 2x in standard form, and then use that to identify the degree and leading coefficient. So again, I'm going to reveal the answer on the count of 3. 1, 2, 3. So now you can go and check yourself. A fun fact is that a polynomial that has all 0 coefficients is actually called the 0 polynomial. And it actually has an undefined degree. So that's just a random fun fact. If you would like more practice with working with the basics of polynomials, be sure to see page A33 of the textbook, numbers 1, 2, and 9 through 14. And in our next video, we'll be talking about operations with polynomials.